Stoichiometry Quiz 1D. Question. A compound contains carbon, hydrogen, nitrogen, and oxygen. Combustion analysis of 0.6465 grams of compound produced 1.105 grams of CO2 and 0.2586 grams of H2O. In another experiment, 0.4485 of the grams of the compound was found to contain 0.1395 grams of nitrogen. The molar mass was found to be 170 plus or minus 15 grams per mole. Find the molecular formula for the compound. First, we have to find the masses of each element. Let's start with carbon. So we know that the amount of carbon produced is 1.105 grams. We'll change that from grams to moles, and then we will use the fact that for every mole of CO2 there is 1 mole of carbon, and then we'll change from moles of carbon to grams of carbon. Then we will do the same process to find the mass of H using 0.2586 grams of H2O, changing from grams H2O to moles H2O. Knowing that there are 2 moles of H for every mole of H2O, and finally changing from moles of H2O to grams of H2O. Then, to find the mass of N, to keep it in line with the rest of the grams, or the masses, we have to start by finding the percent mass of N, because that is a different experiment, and we can't use the same value. So we have to do 0.1395 grams of N divided by 0.4485 grams of compound times 100, which is the mass percent of nitrogen, and then we will use the amount of compound that we have, that we are basing this on, which is 0.6465 grams of compound, and then we will multiply that by 31.1 grams of nitrogen per 100 grams of compound, which is the percent mass ratio. And then to find the mass of oxygen, we have to use our 0.6465 grams total and subtract from it our 0.3010 grams of carbon, our 0.02894 grams of hydrogen, and our 0.2011 grams of nitrogen, and we get 0.1155 grams of oxygen. Now we have all of our masses of all of our elements. We can move on to finding the empirical formula. To find our empirical formula, we will make 4 columns, 1 for C, 1 for H, 1 for O, 1 for N, and we must change everything from grams to moles. So we will start grams C to moles C, grams H to moles H, grams O to moles O, and grams N to moles N. Then, because moles O is the smallest mole value at 0.007219, we will divide everything by 0.007219. Which gives us 3C 3.5, H4, O1, and N2. Because C is 3.5 and we can't have it as a non-whole number, we have to multiply everything by 2, giving us an empirical formula of C7H8O2N4, which we can now use to determine our molecular formula. To find our molecular formula, we must start by finding the empirical formula mass. Our empirical formula is C7H8O2N4, and its mass is 180.1640, and then we divide that by the 170 we were given at the start, and it's fine that our empirical formula is a little higher because we are given plus or minus range of 15, and they're within the range of a 1-to-1 ratio. So our molecular formula is the same as our empirical formula, C7H8O2 and 4.